Dear students, welcome. This is our fourth class on hydrostatics. Today we shall solve some problems. One of the problems has already been written in the board. First, we shall discuss this problem. A closed tube in the form of an equilateral triangle contains equal volumes of three liquids which do not mix and is placed with its lowest side horizontal. Prove that if the densities of the liquids are in AP, their surfaces of separation will be at the points of trisection of the sides of the triangle. Three liquids, a closed tube in the form of an equilateral triangle. A closed tube in the form of an equilateral triangle. Suppose ABC is an equilateral triangle. Contains equal volumes of three liquids which do not mix and is placed with its lowest side horizontal. BC is the lowest side of the equilateral triangle. BC is the lowest side of the equilateral triangle. It is horizontal. BC is horizontal. And you see three liquids of equal volumes. Suppose DEF are 3 points on the sides BC, CA and AB such that BD equal to CE equal to AF. Suppose three liquids are occupied, three liquids which are in AP. Suppose this portion, DCE, this portion is occupied by a liquid of one density, and EAF is also occupied, this portion is also occupied by another liquid, and FBD, this portion is also occupied by another liquid. You see here, and do not mix with its lowest side horizontal. If the densities of the liquids are in AP, means we may assume that the densities of the liquids are rho minus sigma, rho plus sigma, like this. Actually, let ABC be the closed tube in the form of an equilateral triangle. Which is placed with its lowest side BC horizontal, with its lowest side BC horizontal, which is lowest side BC horizontal. ABC is the closed tube in the form of an equilateral triangle, with its BC is the lowest side, it is placed as horizontal. Now let DEF are the points of the sides BC, CA and AB respectively. Let DEF are points of the sides BC, CA and AB respectively such that BD equal to DC, not DC, BD equal to CE equal to AF, this is equal to A, and consequently DC equal to EA equal to FB. This is equal to A minus X, where A is the length of each side of the equilateral, where A is the length of each side of the equilateral triangle. Triangle ABC. Right? Of the equilateral triangle. Now, the densities of the liquids are in AP. Let rho minus sigma, rho and rho plus sigma be the densities of the liquids. Let rho minus sigma, rho and rho plus sigma be the densities of the liquids. Now, equal volumes. Let the column DCE, it is occupied by the density of the liquid of density rho plus sigma, and FBD, it will be rho, and it will be definitely rho minus sigma. Rho minus sigma. Let the columns DCE, EAF and FBD be occupied by the liquids of densities rho plus sigma, rho plus sigma, it will be rho minus sigma and rho respectively. Let we draw perpendicular AO. Suppose this is, we draw perpendicular this one. O dash. O or O dash. AO, AO. From E, draw this. From F, draw this. And suppose this is M. AO is perpendicular. Suppose AO is perpendicular on BC. Suppose that AO is perpendicular on BC. We draw perpendiculars. EL. We draw perpendiculars EL and FM from E and F on AO respectively. Actually, what is this? The tube is in the form of an equilateral triangle. It is of the form of an equilateral triangle. Actually, this portion is occupied by the density of rho plus sigma, and suppose this portion is occupied by the density of rho minus sigma, and suppose this portion is occupied by the density of rho, and it is D, E and F. Actually, the thing is this. This portion is occupied by the density of liquid of density rho plus sigma. This portion is occupied by the density of by the liquid of density rho minus sigma, and this portion is occupied by the liquid of density rho. Actually, this. Now we have now due to equilibrium, you see here equal volumes. Surface of separation. Surface of separation. What is the surface of separation here? You see, D, E, F will be the points of surface of separation, because in this portion D, C, E, one liquid is there whose density is rho plus sigma, and E, A, F, it is occupied by the density of rho minus sigma. Therefore, E and F are also the surface of separation. F, B, D. What are the surface of separation? D, E, F. What we are going to do? Surface of separation are will be at the points of trisection. This means we have to show that points of trisection means BD. This is equal to half of DC. BD will be equal to half of DC. Not only that, CE equal to half of AE and AF equal to half of FB. We have to show this. Now you see, due to equilibrium, pressures on the left side of O equal to pressures on the right side of O. Pressure at B. That means the pressure of, on the left side of O. This is equal to pressure at, that is the left side of O, suppose. This is equal to pressure at, see, what is pressure at C? Right side of O. Actually, we may write like this, right side of O. Pressure at B, this is equal to pressure at C. What is the pressure at B? You mean what will be the pressure on the left hand side of O? You see. Now, what will be the pressure on the left hand side? We have to find the pressure on the left hand side of this. You see, pressure G on the left hand side, you see BDF. It is occupied by the liquid of density rho. Therefore, you will have to write rho here. Rho into depth, surface of separation. It is F. What will be this? OM. It will be definitely OM. Left side. OM. Also, it is occupied by FAE. It is occupied by the liquid of density rho minus sigma plus G rho minus sigma. What will be this? AM. It will be AM. Rho minus sigma AM. This is equal to left hand side is finished. Just let me repeat. Z, it is occupied by density rho and H. What will be the height? OM, it will be OM, perpendicular distance OM. And it is occupied by the density of rho, liquid of density rho minus sigma, G rho minus sigma into this distance AM. This is equal to Z. It is occupied by, we are considering this liquid. You see here, DCE, G rho plus sigma, G rho plus sigma into OL, it will be OL plus G rho minus sigma, it will be AL, it will be AL. it will be AL. This means rho OM can be written as OA minus AM. OA minus AM plus rho minus sigma, it is AM. This is equal to rho plus sigma OL, means OA minus AL and rho minus sigma into AM. Am I right? And it is OL. OL means minus OA. OL. AL. This AM is, oh no, it is not. Rho minus sigma. Oh, I am sorry. Oh, funny. And right hand side rho minus sigma. It is not AM. It is AL. What? Oh, no. Right. AL is written. AL, we have written AL. Rho plus sigma. OL means OA minus AL. Rho minus sigma AL. Yes, it is AL. OM, AM, OL, AL. Yes, right. No mistake has been done. OM means OA minus AM, this is AM, and OL means OA minus AL plus AL. Yes, we have done no mistake. Now you see, this means rho. OA, what is OA? OA is equal to AB. Since it is an equilateral triangle, it will be 60 degree. What is OA? And it will be OAB. AB means A sin 60 degree, right? A sin 60 degree. OA equal to AB equal to A sin 60. AB equal to A sin 60 degree minus AM minus, what is AM? Equal to AF means X sin 60 degree plus rho minus sigma AM means X sin 60 degree. This is equal to rho plus sigma OA. OA means AB sin 60 degree. This means A sin 60 degree. A sin 60 degree minus AL. What is AL? AL equal to AE sin AL. It will be again 60 degree. It is 60 degree and this is also 60 degree. What is AL? Equal to AE sin 60 degree. AL equal to AE sin 60 degree. AE is A minus X. A minus X sin 60 degree. A minus X sin 60 degree plus rho minus sigma AL. AL means, what is AL? Equal to A minus X sin 60 degree. Sin 60 degree. Because what is OA? Equal to AB sin 60 degree. AB equal to A sin 60 degree. AM equal to AF sin 60 degree. AF equal to X sin 60 degree. X also X sin 60 degree. And it is AL. What is AL? Equal to AE sin 60 degree. AE equal to A minus X. You may write here, since AB equal to BC equal to CA, this is equal to A. The length of each side of the equilateral triangle is A. This is equal to A. AF and BD equal to CE equal to AF. This is equal to X. BD equal to CE equal to AF. This is equal to X. Also DC equal to EA. This is equal to FB equal to A minus X. A minus X. Right? Now all sin 60 will be cancelled. All sin 60 will be cancelled. This means rho into A minus X. Rho into A minus X plus rho minus sigma. Rho minus sigma into X. This is equal to rho plus sigma into A minus A plus X. A minus A plus X. A minus A plus X plus rho minus sigma into A minus X. A minus X. This means it will be AA will be cancelled. Now take the coefficients of X on the right hand side, left hand side, and the coefficient of A on the right hand side. It will be minus rho. Coefficient of X minus rho. Coefficient of X plus rho minus sigma. Coefficient of X minus rho minus sigma. Minus rho minus sigma. And this coefficient of X plus rho minus sigma into X. This is equal to, just take the coefficients of A on the right hand side. A, it will be rho minus sigma into A. Rho minus sigma. Rho minus sigma into A. Also, this here is also A. If you take rho A to the right hand side, it will be minus rho. Minus rho times A. Just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 terms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All terms have been written. The coefficient of X, all the coefficients of X have been written on the left hand side, and all the coefficients of A have been written on the right hand side. Now you see minus rho plus rho will be cancelled here. Minus rho plus rho will be cancelled. This plus rho minus rho will be cancelled. Consequently, you will get minus thrice sigma X equal to minus sigma A. This means thrice X equal to A. This means thrice X equal to A. This means X equal to A by 3. X equal to A by 3. X, this is equal to A by 3. Therefore, BB equal to CE equal to AF equal to this is equal to X equal to A by 3. This is equal to A by 3. DC equal to EA equal to FB. It is A minus X. This is equal to A minus A by 3. This is equal to twice A by 3. This is equal to twice A by 3. Right? Twice A by 3. This means, therefore, BD is to DC equal to CE is to EA equal to AF is to FB equal to X divided by A minus X. This is equal to A by 3 divided by A minus X means twice A by 3. Twice A by 3. A by 3, twice A by 3. This is equal to 1 by 2. Equal to 1 by 2. This means BD by DC equal to 1 by 2. This means twice BD equal to DC. Like this. Twice BD equal to DC. Therefore, D, E and F are 3 points on the sides BC, CA and AB, which are at the points of trisection. Thus, the points D, E and F are the points of trisection of the sides BC, CA and AB respectively of the triangle ABC. Triangle ABC respectively of the triangle ABC. Thus, the surface of separation are at the points of trisection of the sides of the triangle. Thus, the surfaces of separation. Thus, the surfaces of separation are at the points of trisection. Points of trisection of the sides of the triangle. Thus, the surfaces of separation are at the points of trisection of the sides of the triangle. Perhaps you have understood this. Very easy. No, D, E and F are the points of trisection of the triangle. Let us take another problem. Let me write the problem here. You see the problem. If the lower half of an uniform circular tube, one quadrant is occupied by a liquid of density twice rho, and the other two liquids which do not mix of densities thrice rho and rho, prove that the volume of the lower of the two latter liquids is twice that of the other. What we are suppose this is the lower half of the uniform circular tube. This is the lower half of the uniform circular tube. Suppose O is the center of the circle, A will be the diameter, bounding diameter. Suppose O dash is this, and one quadrant is occupied by the density of twice rho. One quadrant is occupied by the density of twice rho. Liquid of density twice rho, and the other density is thrice rho and rho. And we have to show? We have to prove that the volume of the lower of the two liquids. Suppose this. C is the surface of separation. O dash C the volume of this portion, is twice that of the other. Volume of the lower of two liquids is twice that of the other. The volume of this. Since we have to find the volume, therefore, you see here in the diagram, we should write like this also. We should write like this. Yes. Suppose this is theta. It is occupied by the density of liquids of density thrice rho, and it is occupied by Now see, let AOB be the bounding diameter. Let AOB be the bounding diameter. Lower half of the circular tube. It is the lower half. AOB. This is the lower portion. It is the bounding diameter of the lower half of the circular tube. Lower half of the circular tube. Let the quadrant. O is the center of the circle. O is the center of the circle. Here O is the center of the circle. Center of the circle. O dash is vertical. O dash is vertical. The quadrant actually it is like this. It is like this. Here in this portion, liquid of density twice. In this portion is occupied by the liquid of density twice rho. And suppose this portion, liquid of density thrice rho, and this portion, liquid of density rho. C is the surface of separation, like this. Actually, this O dash is vertical line. Let the column, this quadrant, let the column AO dash be occupied by the liquid of density twice rho. AO dash is occupied by the liquid of density twice rho. Let the portions, let the columns O dash C and CB be occupied by the liquid of density, by the liquids of densities. Thrice rho and rho respectively. This means C is the surface of separation of the later liquids. Means surface of separations of the liquids of densities thrice rho. This means that C is the. This means that C is the surface of separation of the liquids of densities thrice rho and rho. This means the C is the surface of separation of the liquids of densities thrice rho and rho. Now, from C, you draw perpendicular. CL, suppose. From C, we draw perpendicular. We draw perpendicular. CL on OO dash. From C, we draw perpendicular OO dash. Let COL equal to COL, this is equal to theta. COL, this is equal to theta. Now, due to equilibrium, pressure on the left side of O dash equal to pressure on the right side of O dash. Pressure on the left side of O dash, this is equal to pressure on the right side of O dash, pressure on the right side of O dash. On the left side of O dash, G rho, G not rho, twice rho. G twice rho. On the left side it is twice rho. G twice rho into this distance OO dash. The distance is OO dash. This is equal to OO dash equal to G thrice rho from O dash to the surface of separation. It will be O dash L. O dash L plus G rho from C to the free surface or effective surface, free surface, it will be OL. It will be OL. Now, GG, rho and GG cancel. 2 times of OO dash equal to 3 times of O dash L. O dash L means OO dash minus OL plus OL. This means OO dash equal to minus thrice OL plus OL minus twice OL, it will be twice OL. It will be twice OL. OO dash equal to twice OL. This implies OO dash is equal to 2 times of what is OL? OC cos theta. OC cos theta. OC cos theta equal to OC cos theta. This means OO dash is the radius of the circle. Suppose this is A equal to 2 times of OC also the radius A cos theta, where A is the radius of the circle. OO dash equal to OC equal to A equal to radius of the circular tube or of the circular tube. This means cos theta equal to half equal to cos theta is equal to half means cos pi by cos 60 degree, it will be cos 60 degree means pi by 3. cos 60 degree means pi by 3. This means theta is equal to pi by 3. Theta is equal to pi by 3. You have got theta is equal to pi by 3. Therefore, COL, this is equal to pi by 3. BOC equal to 90 degree minus pi by 3 means pi by 2 minus pi by 3. Pi by 2 minus pi by 3 equal to pi by 6. Pi by 6. This is, it will be pi by 6. And theta is equal to, it is pi by 3. This is pi by 3 and this is pi by 6. Pi by 6. Now, would us see. Would us see this S is equal to A theta means the radius into theta, A into pi by 3. A into pi by 3. Would us C is equal to this CB. CB equal to A into pi by 6. A into pi by 6. S is equal to A theta in a circle. This formula has been applied. Would us C. Would us C by CB equal to A into pi by 3 divided by A pi by 6. This is equal to 2. This is equal to 2. This means would us C equal to 2 times of CB. This is equal to 2 times of CB. Would us C equal to 2 times of CB. This means O dash C into K equal to 2 times of CB into K, where K is the cross section of the tube. Where K is the cross section of the tube. Where K is the cross section of the tube. K is the cross section of the tube. Would C equal to K? 2 times of CB. K is the cross section of the tube. What does it mean? The cross section K into this distance, into this, will be equal to volume. This means volume. Suppose V1 equal to 2 times of CB. CB into K, cross section into CB, it will be the volume. Where V1 and V2 are the volumes. Where V1 and V2 are the volumes of the liquids. Volumes of the liquids occupying the columns or the portions would C and CB respectively. CB respectively. Occupying the columns would C and CB respectively. Hence proved. We are asked to prove that the volume of the lower of the later liquid of the two later liquids. Later liquids thrice liquids whose densities are thrice rho and rho. Lower means what is the lower? Lower liquid will be equal to thrice rho, and upper liquid is equal to rho. Therefore, volume of the liquid of density thrice rho is twice the volume of the density rho. That is this. Therefore, the volume of the liquid of density twice rho. This is equal to 2 times of volume of the liquid of density. This volume of the liquid of density twice rho equal to 2 times of volume of the density, liquid of density rho. This proves the question. Let us take another example. Let us take Let us see the question. 3 liquids whose densities are in AP. The densities of the liquids are in AP. Filled a semicircular tube whose bounding diameter is horizontal. You see the bounding diameter of the semicircular tube. Bounding diameter is horizontal. Bounding diameter is AOB, is the bounding diameter of the tube. It is horizontal. The bounding diameter of the tube is horizontal. Bounding diameter is horizontal. The depth of one of the common surface, is double depth of the other. Suppose O dash is the lowest point. C and D are points. CL, DM. AC, this portion is occupied, suppose DC, O dash D, it is occupied by the density, liquid of density rho plus sigma. Obviously, it will be rho and it will be rho minus sigma, occupied by the liquids of density. What are the common surfaces? C and D are common surfaces. C and D are the common surfaces. We have to show that depth of one of the common surface, OC is equal to 2 times of OM. I am writing here. Thus M should be here. Suppose B. We have to show that depth of C below the effective surface is twice the depth of D below the effective surface. Below the effective surface above the diameter. 3 liquids whose densities are in AP filled a semicircular tube whose bounding diameter is horizontal. Now, let me proceed. Let rho minus sigma, rho and rho plus sigma be the densities of the liquids, of the 3 liquids. Be the densities of the 3 liquids. The bounding diameter is horizontal. Let AOB be the bounding diameter. Let AOB be the bounding diameter of the semicircular tube AOB the bounding diameter of the semicircular tube which is horizontal. You may write which is horizontal. Let AOB be the bounding diameter of the semicircular tube which is horizontal. O is the center of the semicircular tube or circle. O is the center. O is the center of the circle. Here the semicircular of the circular tube. Let O dash be the lowest point of the semicircular tube let O dash be the lowest point of the semicircular tube. Let O dash be the lowest point of the semicircular tube. O dash is vertical. O dash is vertical. It is clear. O dash is vertical. Common surface or surface of separation. Let C and D be the surface of separation. Let C and D be the surface of separation or common surface. Surfaces of separation of the liquids. What does it mean? In other words, we may write, let the columns AC, CO dash B, CD and DB be occupied by the liquids of densities rho plus sigma and rho minus sigma respectively. In other words, you may write like this. The columns AC, CD or CO dash D, you may write like this, CO dash D, CD and DB be occupied by the liquids of densities, rho plus sigma and rho minus sigma respectively. Rho plus sigma and rho minus sigma respectively. Now we draw perpendiculars. CL and DM from C and D on O dash from C and D respectively, you may write here respectively on O dash, we write like this. What should we prove? We have to show that OL equal to 2 times of OM. We have to show that. This is our aim. We have to show that. OL equal to 2 times of OM. We have to show this one. We have to show that OL equal to 2 times of OM. 2 times of OM. Now, due to equilibrium, pressure on the left side of O dash equal to pressure on the right side of O dash. Pressure on the left side of O dash equal to pressure on the right side of O dash. Pressure on the right side of O dash. Pressure on the right side of O dash. This means, you see here, let's say 0 into this distance will be equal to OL. 0 OL plus, it is occupied by the left side, it is occupied by the density, by the liquid of density rho plus sigma, 0 plus sigma, rho plus sigma into the vertical distance from O and C, it will be O dash L. It will be O dash L. This is equal to Z, it is rho plus sigma. Rho plus sigma. What will be this distance? O dash m. O dash D, vertical distance of O dash from D. It will be O dash m. O dash m. Plus Z rho minus sigma. I am writing here. Plus Z rho minus sigma into this distance OM. This distance. In this case, we have to find, we have to show that OL is equal to OM. Means the relation between OL and OM. OL and OM. Here you see GG will be cancelled, rho into OL. Plus rho plus sigma. O dash L. O dash minus OL. O dash minus OL. Right here. This is equal to rho plus sigma. O dash M. O dash minus OM. O dash minus OM. Plus rho minus sigma. Rho minus sigma OM. Rho minus sigma OM. Right? Rho into OM, yes. What is O dash? Is the radius of the circle. O dash is the radius. Here you see rho plus sigma into O dash. Rho plus sigma into O dash. Rho plus sigma into O dash will be automatically cancelled. Will be cancelled. This means rho into OL minus rho plus sigma into OL, because these two terms will be cancelled, equal to minus rho plus sigma into OM plus rho minus sigma into OM. This means you may write rho minus sigma into OL equal to minus rho minus sigma plus rho minus sigma into OM. Now plus rho minus rho will be cancelled. Will be cancelled. Here also plus rho minus rho will be cancelled. Now see. This means minus sigma into OL equal to minus twice sigma into OM. This means OL equal to 2 times of OM. Means the depth of one common surface is twice the depth of the other. Depth of one of the common surface, one of the common surfaces, it should have been one of the common surfaces. Depth of one of the common surfaces. Two common surfaces there, common surfaces is double depth of the other. What is this? This means the depth of one of the common surfaces. C and D are two common surfaces. Depth means its depth from the bounding diameter. Means from O, the vertical distance. That is, this means the depth of one of the common surfaces. Of the common surfaces is double depth of the other. Therefore, the depth of one of the common surfaces is double depth of the other. It is very easy. Not some more problems will be solved in the next classes. Perhaps another 5 or 6 questions will have to be solved. After that, we shall discuss the next chapter. We shall go to the next chapter. Today, I want to stop here. Thanks for attending the class. Thank you very much.